Your phone unlocks by recognizing your face. ChatGPT writes entire essays in seconds. A car drives itself down a highway. An AI diagnoses cancer from a scan before any doctor looks at it.
These are not four different technologies. They are four applications of one idea, deep learning. And in the next 72 episodes, you are going to understand every layer of how it works.
I've spent the last 114 episodes taking you from your first print statement to train machine learning models. This series is the next level. Not just using deep learning, understanding it well enough to build anything.
I'm Mahaz. Welcome to the Deep Learning series. This first episode answers the questions every other tutorial skips. What deep learning actually is, why it suddenly became so powerful, what it can and cannot do, and what tools you will use throughout this series. Start with the three terms everyone confuses: artificial intelligence, machine learning, and deep learning.
Artificial intelligence is the broadest term. Any technique that makes a computer behave in a way that looks intelligent. Rule-based systems, search algorithms, game trees, all of that counts. Machine learning is a subset of AI. Instead of programming the rules by hand, you give the computer data and let it find the rules itself. You've spent the last series doing exactly this. Deep learning is a subset of machine learning. Specifically, it uses neural networks with many layers. The deep refers to the depth of those layers, not to some mystical complexity. So, AI contains ML, ML contains DL. Deep learning is not a replacement for everything before it. It is the most powerful tool in the toolbox for certain types of problems. What is deep learning actually doing? Here's the intuition before we touch any math. Take a photo of a cat. A classical program would need you to write explicit rules. If there are triangular ears, whiskers in this position for legs, then cat. That fails the moment the cat is upside down or the photo is blurry. A deep learning model does something different. You show it a million photos, each labeled cat or not cat. The network starts as random noise. It makes a prediction, finds out it's wrong, and nudges every connection slightly in the right direction. Do that correction millions of times across millions of examples, and the network gradually learns to detect edges, then shapes, then ear shapes, then the concept of cat, all without anyone writing a single rule about what a cat looks like. That's self-organization of knowledge from raw data. That is the core idea. The layers are stages of increasingly abstract pattern detection, stacked so each layer builds on what the layer below it found. Neural networks are not a new idea. The perceptron was invented in 1958. So why did deep learning only become dominant in the last 10 to 15 years? The first force, data. Deep learning models need vast amounts of training data. The internet, smartphones, and digitization of everything created data at a scale that simply did not exist in the 1990s. The second force, compute. GPUs, graphics cards originally built for video games, turn out to be perfect for the kind of parallel matrix arithmetic that neural networks require. Training that took months in 2005 takes hours now. The third force, algorithms. Breakthroughs like ReLU activation, dropout regularization, batch normalization, and the transformer architecture solved problems that were making deep networks nearly impossible to train. The fourth force, open source tooling. PyTorch, TensorFlow, Hugging Face, and thousands of pre-trained models made it possible for one engineer to do in an afternoon what required a research lab in 2012. All four forces arrived together. That collision is why deep learning didn't gradually improve. It transformed everything at once. What does deep learning actually power in the real world right now? Computer vision, photo recognition on your phone, medical imaging that detects tumors, quality control systems in factories that spot defects faster than any human inspector, and the perception stack in self-driving vehicles. Natural language, the large language models behind ChatGPT, Gemini, and Claude. Real-time translation across 100 languages. Code generation tools that write working software from a plain English description. Audio and speech. Voice assistants that understand natural speech. Music generation models that can write in any style, and noise cancellation systems that strip background sound from a phone call in real time. Generative models, DALL-E and Stable Diffusion create photorealistic images from text. Sora generates video. AlphaFold predicted the 3D structure of virtually every protein on Earth, a problem that had been unsolved for 50 years.
Biology, chemistry, materials science, climate modeling, drug discovery. The applications are expanding faster than any single list can track. This is why deep learning is the single most important technical skill to understand right now. Where does deep learning actually appear in industry, and what roles use it?
Machine learning engineer, building, training, and deploying models. The role that every classical ML concept you've learned was preparing you for. Deep learning is now the core of this role. Research scientist, pushing the state of the art, designing new architectures, writing papers, running large-scale experiments at companies like Anthropic, DeepMind, and OpenAI. Applied AI engineer, taking existing models, often pre-trained, and fine-tuning or integrating them into products. This is where most of the industry jobs actually are. Data scientist with DL skills, classical ML plus the ability to apply neural networks when the problem demands it. The combination is more employable than either alone. The point is not that you must become a researcher. The point is that understanding deep learning is now a baseline expectation in almost every AI-adjacent role. Two tools dominate deep learning in 2025. You need to know both, but you need to learn one first. TensorFlow was built by Google. It dominated industry from 2015 to around 2019, particularly for production deployment. TensorFlow Serving and TensorFlow Lite are still widely used in mobile and edge deployment. PyTorch was built by Meta. It took over research almost completely after 2019 because it runs like regular Python. You can step through your network with a debugger and inspect every tensor at any point. Much easier to understand and experiment with. Industry followed research. Most new production systems are now built in PyTorch. It is the primary tool we will use throughout this series. We will cover TensorFlow where relevant, especially for deployment. For GPU access, Google Colab gives you a free GPU in a browser with no setup. Kaggle notebooks give you more GPU hours per week. If you have an NVIDIA GPU locally, we will show you how to configure CUDA. The examples in this series will run on all three.
72 episodes. Here is what you are signing up for.
Module 1 and 2. Introduction and the Mathematical Foundation. Tensors, linear algebra, calculus for backpropagation, and probability. None of it is abstract. Every piece of math is immediately connected to a line of code. Module 3 and 4. Neural network fundamentals and training. Building a perceptron from scratch. Forward pass, backpropagation, optimizers. Your first real NIST classifier in PyTorch. Module 5 through 7. Convolutional networks, sequence models, and the transformer. This is where you go from basic classifiers to the architectures that power image recognition, translation, and language models. Module 8 and 9. Generative models and NLP. GANs, Vs, diffusion models, BERT, GPT, fine-tuning with LoRa, retrieval-augmented generation, and building a working chatbot. Module 10 through 15. Reinforcement learning, specialized architectures, scaling, optimization, deployment, explainability, and 3 capstone projects you can put directly on your portfolio. Every episode follows the same structure. Concept first, math made visual, then code that runs. No episode assumes you already know the next one. The series is designed so that someone who finishes it is employable. Recap. What you now know going into every episode that follows. AI is the broad category. Machine learning is learning from data. Deep learning is machine learning with layered neural networks. And it is the engine behind almost every impressive AI product of the last 10 years. Deep learning is powerful now because 4 forces converged at the same moment. Massive data, cheap GPU compute, better training algorithms, and open-source infrastructure. It powers computer vision, natural language, audio, and generative AI, and the applications are growing faster than any person can fully track. PyTorch is the primary tool. Colab or Kaggle gives you the GPU you need right now. Every episode from here is code first. Your challenge for this episode: list 3 products you use daily that run on deep learning. For each one, identify whether it is vision, language, audio, or something else. Look it up, check your guess, and post what surprised you in the comments. Every technology that looks like magic has a mechanism underneath it. Deep learning is not magic. It is matrix multiplication, gradients, and a loop that runs until the numbers converge.
But when those three things run on enough data with enough compute, the result changes what software can do, permanently.
Next episode, why classical machine learning hits a ceiling and exactly where deep learning breaks through it.
Subscribe. The series is already underway. See you in episode 2.